And we should only be doing this. So if we look at this, this tries to grab the lock, does a bunch of shit, and then releases it. This is on the main thread. This is on a background thread. I'm kind of surprised by that behavior. If we don't kill the thread, it deadlocks. I'm actually kind of surprised. Oh, p-thread join immediately after. Yeah, okay. I mean, that'll do it. I don't know what's gonna happen here. Okay. Abort trap. And that's if we don't kill the thread. Right, because as soon as we release the mutex, it's going to try to use all this stuff. I'm surprised it's not a sec fault. Though we should set that up, right? Like probe. Where is it? Pipe audio. Probe for audio devices. Yeah, we should set all this. Oh, it does all of them? I don't think that matters. We only have one. We should free that. This is interesting. I'm kind of surprised by that. What's the problem with GDB? It really struggled. Oh, yeah. Yeah. This is sad. We'll get there. No, we won't. You can't find a symbol? XCB. An XCB symbol? Yeah, that's got nothing to do with me. Okay. Okay. So we have the same problem. Mutex contention. Right, so what would be happening here? Let's see if we can get some printfs going. Locked. Dialect. I don't know if they'll be flushed, but we can hope. Probed. Piped. Unlocked. Okay, click, click. Locked. That's as far as we got. So you're saying that dialect is my theory, which I think would be silly if true, big if true, is that sig term is being sent to a whole process, not just the thread ID. Because, I mean, the default signal handler could be to access the process. I mean, that would be kind of silly, but though, frankly, I'm kind of surprised we can't carry on. So we got an abort, but I'm surprised. Okay, my audio cut out again, but I didn't notice. In fact, I misattribute the later crash to cutting out my audio. So I'll just provide a bit of voiceover in between now and when I later catch that my audio is gone. So this whole time, I'm pretty unhappy with the prospect of adding a mutex to all this. It's a pretty ugly design, and the whole time I'm pretty concerned that it's going to be slow, because locking and unlocking mutex is pretty slow, and this looks like it's going to lead me down the path of having to lock the mutex basically all the time. We can already see glimpses of it here. Just wait. I think I maybe end up killing the program. Wow, I'd wait quite a long time on this. Yeah, I do end up killing the program. So that sort of thing, trying lock contention for the lock, that ends up being a huge issue. And anytime we want to change like we're doing here, change the output, the name of the output file, you get these huge pauses that are unpredictable in length. Am I going to demonstrate it again? Yeah, demonstrate it again. See, that one, we managed to grab the lock fairly quickly. It was only a pause of about maybe 2 seconds-ish. This one, yeah, that one, it looked like we had a different issue with the Muxa. No, it was the same issue. Yeah, so there you could see it was like a good maybe 5 seconds that we were trying to get a hold of this lock. But there's huge contention for it between the UI thread and the processing thread. So it's really it's a pretty ugly design. And really just kind of untenable. Like we can't work with that sort of contention. Locking up the entire UI thread for like 5 seconds is not good enough. But for this episode, we'll continue on with it. this episode. So here I'm trying to look to see if there are any attributes I can use to make this contention not as much of a problem. It doesn't look like there are. Indeed, I think I take a glance at this and maybe not conclude, but leave wondering what attributes I can even set on a mutex, since I don't think it was particularly clear. Though we did discover the problem of why we were terminating before, which is basically the default sigterm handler for any thread is to abort the process. So what was happening was that we would send a sig abort to, or a sigterm, to our processing thread. Our processing thread, yeah, okay, it would get it on that thread specifically, but that thread's handler was to kill the entire process. So the entire process would come down. And so now we're looking at how to defeat that. But really this whole design is wrong around using around killing threads from the outside. It's a pretty dubious thing to kill a thread. Like, if you have any amount of state that you need to maybe flush, like we do, then just killing a thread will leave your state inconsistent. In particular, we're holding onto a mutex. Killing a thread that's holding a mutex is, I don't know if that's strictly undefined or if it's trying to use the mutex in any way afterwards is undefined, but it's not good. You shouldn't do that. Really, the right way to do this is pass a message to the thread telling it to kill itself, as as macabre as that sounds. And we'll settle on that design eventually, but it won't be now. I have to come back and revisit this later to fix it up. I wonder if that include of signal.h is still in the code. I think I should remove it if it is. Yeah, so here when launching a new thread, we're going to have that thread just basically get rid of its signal handler. Or its sigterm handler at least, to make it so that it doesn't take down the entire process. Yep, so here we set the sigterm handler to, I believe we ignore it? No. Yeah, because I guess we do want to deallocate all the resources in this. I mean, we don't want to do this at all, but assuming that we're going to, we want to deallocate all the resources in this thread. So calling exit thread makes sense, rather than just ignoring the signal, because you do actually want to. We are intending to take down the thread so that we can respawn a different processing thread.